Today we are going to talk about Poynting theorem and Poynting vector in the chapter electromagnetic field theory. So, Poynting theorem is related to electromagnetic waves. When it's traveling in space, it carries energy and energy density, which is always associated with electric and magnetic fields. The rate of energy traveled per unit area, or the amount of energy flowing through per unit area in the perpendicular direction to the incident energy per unit time, is called Poynting vector. Poynting vector is represented as conservation of energy in electromagnetics, and it is Poynting vector is represented either by P or S, and that is equal to E cross H, where E is the electric field, H is the magnetic field, and direction of Poynting vector is perpendicular to both E and H. Poynting vector is also known as instantaneous energy flux density, and the unit will be, basically it represents in a rate of energy transfer per unit area, so unit will be watt per meter square. And Poynting theorem tells you about conservation of energy in electromagnetic waves when they travel. And Poynting theorem tells you that net power flowing out of a given volume V is equal to the time rate of decrease of stored electromagnetic energy in that volume decreased by the conduction losses. Total power leaving the volume is equal to rate of decrease of stored electromagnetic energy minus ohmic power dissipated due to motion of charge. What it means is a wave is passing through, it is supposing this in a room, electromagnetic wave is traveling through this room. What it does is, first of all, it is carrying some energy. So if there are charges in this room, some work will be done to the charges, so its energy will be decreased, and when finally it will go out of the room per unit area, that tells you about the Poynting vectors. So let's understand it more. First we go further. So let's first derive the equation, then we'll have a better understanding. So we write Maxwell equations in free space. Okay, so divergence D, there are no, here we are trying to in a and just assume there are no charges here. So divergence D is equal to 0 instead of rho. Divergence B is equal to 0, Maxwell's second equation. Curl E is equal to minus del B by del T. Curl H is equal to J plus del D by del T. That is Ampere's circuital law. Last equation. Third equation is what? Faraday's law. Now what we do is, now first of all we take a curl scalar product of third equation number 3, Maxwell's third equation, with H, and Maxwell's fourth equation with E. Both sides take a dot product with H in third and E with fourth. So we get equation number 5 and 6, as you can see. Then what we do is we subtract them. H dot curl del cross E minus E dot del cross H is equal to, right hand side we get these equations. Now these factors we'll group together, minus H dot del B by del T and minus E dot del D by del T, we'll make a group, minus E dot J. We'll keep it a little separate. So on the left hand side of this equation, H dot curl E minus E dot curl H, we use a identity. What is that identity? We use a mathematical identity from vector analysis. Divergence of A cross B is equal to B dot curl of A minus A dot curl B. So instead of A and B, here we have E and H. So divergence of E cross H is equal to, we will write the first term we'll get, H dot curl E minus E dot curl H. So left hand side in the first equation is replaced by divergence of E cross H. And then the right hand side is written in the same way. So now what we do is, instead of B, we write mu H. Instead of D, we write epsilon E. We substitute it inside and we do a little mathematical, what I do is, instead of mu will be a constant will come out, and in H dot del by del T of H, instead of that I'll write half mu del by del T of H square. So what will I get? Half mu del by del T of H square. H square will give you 2H. So half cancels and it will come out to be the same. So instead of H dot del B by del T, we can write del by del T of half H dot B. Similarly, E dot del D by del T, we will simply write half del by del T, half of E dot D. So in the equation, we'll put it back. So what we get is divergence of E cross H is equal to minus del by del T, half of H dot B plus E dot D minus E dot J. Now left and what I'll do is, I'll take E dot J to the left and other factors to the right, and then I take a volume integral of the whole equation, all terms. E dot J dV is equal to volume integral of del by del T half H dot B plus E dot D minus divergence of E cross H dV. This is also, I'll take the volume integral. Now in this equation, just look at the last term, divergence of E cross H. Now divergence of E cross H can be written as, if you remember your Gauss theorem of Gauss divergence theorem, divergence of a vector, if I take a volume integral, I will get what? I will get that vector and I'll get the surface integral of the same thing. So divergence of E cross H dV will give you nothing but E cross H dot ds, surface integral. So I'll replace it here. Instead of a volume integral, I'll take a surface integral in this equation. So here I'll get E dot j dV is equal to minus del by del T of this term, and the second term is E cross H ds. Okay. So now again I'll take E cross H to the left and other terms to the right. Now in order to understand what's happening here is, here half mu H square is basically the energy carried by the magnetic field, and half epsilon E square is the energy carried by the electric field. In the electromagnetic fields, half mu H square is the part which is carried by the magnetic field, and half epsilon E square is the part which is carried by the electric field. So instead of this complicated term, I will simply write UEM, electromagnetic field, and we have a del by del T, rate of change of electromagnetic field, and E dot J dV also we have. So E cross H we have already defined as P or S. So if here I replace this by P dot ds, P is the Poynting vector, is equal to rate of change of the electromagnetic field which is in the whole of the volume, or rate of decrease of stored electromagnetic energy. And E dot J, we will just discuss it further. It is nothing but the power which is dissipated of the field because of the charge motions. Okay, now, so this part is okay. Half mu h square is the magnetic energy, half epsilon E square is the electrical energy. Total will be the electromagnetic energy. What is the rate of decrease of stored electromagnetic energy? Now this second term E dot J or J dot E is why are we saying that it is the power dissipated by the field because of the charges present? We just consider this equation you already know. This is the Lorentz force law. F is equal to force is equal to QE plus V cross B, right? Now work done is F dot ds. So if work done is F dot ds, rate of work done is F dot ds by dt. So V can ds by dt can be written as V is velocity. So F dot V is equal to, if I replace the factor F here, you will realize that it is nothing but because dot product with V cross B dot V will be 0. So we will just be left with QE dot V. Now if the number of particles, the particle density, particles per unit volume is n, so rate of work per unit volume is nf dot v, and that can be written as j dot e. So j dot e is basically not what? It is the power uh, which is used up of the field because of the charges present. So now, so total power leaving the volume. So what happens is the electromagnetic field is coming and it has some energy. So the electromagnetic energy is decreasing as it travels, and also it is doing some work on the charges. So the difference of these two things will be what is left with the electromagnetic energy. So total power leaving the volume is equal to rate of decrease of stored electromagnetic energy minus ohmic power dissipation due to the charge motion. So this equation, which is written in English, is basically Poynting theorem, and according to which net power flowing out of a given volume is equal to the rate of decrease of stored electromagnetic energy in that volume minus the conduction losses. So P dot ds is E cross H dot ds represents the amount of electromagnetic energy crossing the closed surface per second, or the rate of flow of outward energy through the surface S enclosing volume V. That is, it is the Poynting vector. Okay. E cross H dot ds or P dot ds is how much electromagnetic energy per unit time is leaving the surface, and which will be perpendicular to the surface. And that will be equal to what? Rate of change of electromagnetic energy in that volume minus how much work it has done, how much power it has dissipated. So, so this basically, this whole equation is nothing but it can be also known as the work energy theorem in electromagnetism, or the energy conservation law in electromagnetism. So Poynting vector and after that Poynting theorem is uh, the work energy theorem in electromagnetism. Thank you.